Right now, there are more than 8 billion of us. We've been to the bottom of the ocean and the surface of the moon. We've named every mammal bigger than a house cat and quite a few smaller. We are, by any measure a biologist would use, an absurdly successful species, spread across every continent, every climate, every altitude short of the death zone on Everest. It is frankly hard to imagine a version of the world where humans just don't make it. But that version of the world nearly happened. More than once, not in some speculative what if an asteroid hits us way. In a documented, written into our genome, we can still see the scar tissue way. And the evidence isn't buried in some myth or prophecy. It's sitting inside your own cells right now, in the DNA you're using to read this sentence, patiently waiting for someone with the right software to go looking for it. Let's start with the strange one. In 2023, a team of geneticists ran a new kind of statistical model, something called FitCol, built to reconstruct population sizes way further back in time than older tools could manage. They fed it genetic data from over 3,000 people alive today, African and non-African populations both, and asked it to work backward, not to what our ancestors looked like, to how many of them there were. The answer came back strange enough that they checked it twice. Somewhere between roughly 930,000 and 813,000 years ago, our ancestral population appears to have collapsed to about 1,280 breeding individuals, not 1,280,000. 1,280 full stop, roughly the head count of a small high school, standing in for the entire future of the human lineage. And this wasn't a bad week. The model suggests this lasted for something like 117,000 years. For context, that's longer than Homo sapiens as a species has existed at all. Sit with that for a second. For over 100,000 years, essentially the entire future of humanity was riding on a population smaller than most sports stadiums, generation after generation after generation, with no way of knowing it was happening and no guarantee it would end. Now, I want to be upfront about something, because this is where it gets interesting, rather than just terrifying. Not everyone agrees this happened the way the model says. Other researchers have gone back through the same data with different methods and come away suspicious that what looks like a bottleneck might actually be a statistical artifact, a quirk of how the tool handles ancient migration patterns rather than a real physical collapse in headcount. Population genetics working this far back in time is a bit like trying to reconstruct a car crash from the tyre tracks a million years after the road got repaved. The signal is real. What exactly it's a signal of is still being argued over in journals right now, but here's what nobody disputes. Something happened around then. The timing lines up almost too neatly with one of the strangest events in our evolutionary history. The moment two separate chromosomes fused together into what's now human chromosome 2. Every other great ape has 48 chromosomes. We have 46. Somewhere in that same rough window, our lineage's genetic architecture itself got rearranged right around the time our numbers may have created. Cause, effect, coincidence. Take your pick, because the honest answer is scientists aren't sure yet. And even the something happened part isn't as settled as it sounds. Researchers digging back through the fossil record for that same window, 813,000 to 930,000 years ago, keep finding evidence that early human species were living across an awful lot of the planet at the time. Sites in China, Kenya, Ethiopia, Italy, Spain, the UK. If a population really had crashed down to a head count you could fit in a school gymnasium, you might expect the fossil record to go quiet somewhere, at least for a while. Instead, it looks almost suspiciously busy. One explanation is that the crash was real but localized, devastating to one lineage in one region while others carried on elsewhere, invisible to a model that's only looking at modern human ancestry. Another is that the model is picking up something else entirely, dressed up to look like a crash. Both explanations are still on the table, and the people who found the fossils and the people who ran the model are, at this point, essentially staring at each other across the evidence. If that bottleneck feels too abstract, too deep in prehistory to really land, here's one that's easier to picture, because we can watch the rock that, maybe, did it. About 74,000 years ago, a volcano in what's now northern Sumatra didn't just erupt. It went off with a force so large it's hard to describe using the word eruption at all. Toba ejected somewhere in the ballpark of 2,800 cubic kilometres of material, enough by some comparisons to bury the entire United States under more than a foot of ash. Ash from that single event has been found as far away as India, China, and the floor of the Arabian Sea, a layer of fine white dust settling over an area roughly the size of the continental United States, sometimes more than a foot deep, thousands of kilometres from the source. To put the scale in perspective, Mount Pinatubo's eruption in 1991, the one that measurably cooled the entire planet for about a year and painted sunsets red across 3 continents, ejected somewhere around 10 cubic kilometres of material. Toba put out roughly 280 times that. It's not really a bigger version of a volcano you've heard of. It's a different category of event, one we haven't seen a repeat of in the entire span of recorded human history. For decades, the leading theory, the Toba catastrophe hypothesis, held that this eruption triggered a volcanic winter so severe it nearly ended us. Global temperatures dropping, years of failed harvests if you can even call foraging a harvest, human population already thin and scattered crashing down to somewhere between 10 and 30,000 people worldwide. Global, total, 10 to 30,000. It's a genuinely great story. It's vivid, it's cinematic, it fits the vibe of one bad day nearly erased our species. And for a long time, it was the explanation you'd find in almost every textbook chapter on human origins. It's also, according to a growing pile of more recent evidence, probably not quite what happened. Archaeologists digging at sites blanketed in actual Toba ash, not theoretical ash, the real stuff still in the ground, keep finding tools, continuously. Before the eruption, during it, after it. In India, people were apparently still napping stone and going about their business with volcanic dust falling around them. Climate models have gotten more sophisticated too, and the newer ones suggest the cooling wasn't the uniform global catastrophe once assumed. Parts of the northern hemisphere may have dropped several degrees, sure, but much of the southern hemisphere barely flinched. The genetic bottleneck is very likely real. The idea that Toba personally caused it is looking shakier every year, and these two aren't even the only candidates on the table. Geneticists have flagged other smaller dips in the record too. A possible squeeze around the time modern humans first pushed out of Africa. Another hinted at during the depths of the last ice age, when glaciers locked up so much of the planet's water that entire coastlines we'd recognise today simply didn't exist yet. None of these are as dramatic as a 98% die-off, but stack them up and a pattern starts to emerge. Our species doesn't have one origin story where we scraped by. We seem to have several, spaced out across hundreds of thousands of years, each one a separate roll of the dice that could have come up differently, which leaves us in a strange spot, honestly. We're now fairly confident our species nearly vanished at least twice, possibly more, and we're not entirely sure why any of those times. There's something almost unsettling about that. We like our extinction stories to have a villain. An asteroid, a supervolcano, something with a name and a date you can point to on a timeline, something you could theoretically have seen coming and dodged. What the evidence increasingly suggests instead is quieter and stranger. A species scraping by for tens of thousands of years on numbers too small to feel safe, undone by nothing more dramatic than a shifting climate, and a run of bad luck long enough to count in geological time rather than a human lifetime. No comet, no single cataclysmic afternoon anyone could have pointed a camera at. Just generation after generation doing the ordinary work of staying alive, finding water, finding food, raising children who'd go on to do the same, without any way of knowing how close to the edge they actually were, because the edge in this case wasn't a cliff. It was a slope so gradual it took hundreds of thousands of years and a supercomputer to even notice it had happened at all. That's the part that stays with me, honestly. Every disaster movie ever made assumes you'd know. Sirens, red skies, a scientist yelling at a general. But the two closest calls we can actually point to in our own species' history didn't look like anything while they were happening. They looked like an ordinary Tuesday repeated for a few thousand generations in a row, which raises the only question that really matters here. Not what almost killed us, but how would we even know if it were happening again? Slowly, quietly, right now. Too gradual for anyone alive today to be the one who notices.